Today we'll continue applications of normal distribution. So previously we looked and worked with the standard normal distribution, and that means that mu is equal to 0 and the standard deviation is 1. So on the middle of the curve you have these two things. Okay, that is your standard normal curve. Today we will look at normal distribution having any mean and any standard deviation. So any mean and any standard deviation we'll be looking at. So the graphs basically will look the same, just that in the middle you wouldn't have mu is 0 and sigma is equal to 1. Okay. So if you recall that the standard normal curve is a bell curve anyway. Okay. And if we draw this curve, okay, so the graphs are basically the same. Here we have mu. Yeah. Some mu equal to some number, could be any number, but here in the standard normal curve, mu is equal to 0 and sigma is equal to 1. So this is standard. In this example here, mu doesn't necessarily have to be equal to 0 and sigma is not equal to 1. So if you look at this, remember the probability, okay? The probability is usually the area of the shaded region. So in either one of these graphs, this shaded region here, okay, represents some probability P. Okay, it doesn't matter. Where this is some X value, usually this is a Z value. And that's something to note, that under the normal curve, this axis here is the Z axis. So how do you convert from this one here that we call the normal or non-standard, okay, non-standard normal distribution? Okay. Well, there's a formula that we can use, okay, and that formula is Z equals X minus mu divided by sigma. So this here is the formula we'll use to convert. This is how you get from non-standard to standard. Yeah. So all we're looking at is how do we get from non-standard to standard. Once we have standard, we can find our probability. Any questions?
No.
Okay. So if we look at an example, okay, if we look at some example, this is what we call a non-standard normal distribution. And it is a non-standard normal distribution because these things here, for it to be standard, this has to be 0, this has to be 1. Okay? So a few things to note. When it's non-standard, okay, this axis here that you're seeing in the bottom, this axis here is not a z-axis. That's an x-axis. Okay? So realistically, what should happen is that this black line here that they have, okay, should really be labeled X. And that's something you will have to know, okay? So how do we move from this picture here, okay, to this standard normal picture? Well, this is X equal over here, okay? So we want to find out what is this X value equal to in reference to a Z value, because when we draw back this diagram, okay, we want to be able to draw this diagram, okay, and we cannot write here that X is equal to 18. We cannot write X equal, no, because this line here is the Z axis. What we need to write is take out this here and write Z equals, okay? And to do that, we're going to use the formula. Z is equal to X minus mu divided by sigma, right? Because I'm going back here. I want to convert from a non-standard to a standard, okay? So we're going to use that formula. And then we plug it in. So Z is equal to, mu is given to us as 100. Mu is given to us as 100, sigma is 15. But what is X? If you notice in this picture here, this is the value of X, okay? So we'll write 118 minus, we said mu is 100, divided by sigma, which is 15. So Z is equal to 18 over 15. And if you get your calculators out, 18 divided by 15 is 1.2. So Z is equal to 1.2. Now, please remember, okay, when you look up Z values on the table, okay, when you look up Z values on the table, which I think I should be able to notice that your Z values on the table are 2 digits number, right? That's too big. These values here are 2 digits. Okay. Any one of these values are 2 digits number. So what you should do is round this value here that you have to Z is equal to 1.20. No matter if you get a 4 digit, if it has a bunch of decimals here, you need to round it to 2 decimal place. Okay, why? Because in your table only works with 2. So therefore, this value here would be 1.20. And don't forget, you want the area of this shaded region here, right? This is what you want to find. So you've basically taken, you see, you can't go on the table and look up 118, right? You cannot go on your table and look up 118 from this picture. So you've converted that picture to this picture here. So you're going to go on your table and look up Z is equal to 1.20. So realistically, the probability now, right? The probability of x less than 118, right? This is this picture here. And I know less than because it's towards the left, okay? This is the same as if I say it's the probability of z less than 1.20. And that is equal to now, if I go back and insert, I think I have the right picture. Maybe this one here. Okay. This is all negative, so I need the positive one. So we're looking for 1.20, okay? So if I get my highlighter, 1. Oh, too big. 1.2 would be here, but 1.20 is above here. So where does those two intersect, I'm really looking for this number here. Do you agree with that?
Yes.
Which is 0.8849, okay? 0.8849. So where does the two of them match up? That's where I'm looking at. Okay, that's how we read the table. Okay. So the probability here is, what did we say? 0.8849. 0.8849. So I'm going to leave this picture here so at least we can see it back and forth. Okay. So that's how you convert from a non-standard to a standard. All right. Okay. Any questions? Questions? Okay. So let's see now if we can find a problem that's a word problem. Or let's look at another picture. Let's look at another example. Did I call this example 1? No, we just call it example. So let's look at another example. Okay, example. So I'm going to go back to your textbook. And take back a picture of this. And now we want to focus on this one here. Okay. So right now, same scenario, right? We're given that mu is equal to 100 and sigma is equal to 15. Okay. The number in the bottom here, which you can hardly see, it's 91. So keep in mind, this is x equals 91, right? Because this is non-standard. Yeah, this is a non-standard. So we have to convert from a non-standard to a standard. So what we want, you guys have to draw a picture, right? I know it sounds harsh, but with the picture really helps you guys when you draw a picture. So we want to know, okay, there's our graph. Okay, we want to know when x is 91, what does that convert to in a z scenario? Because now we have this is the z-axis. Over here, this was the x-axis. Okay. So what is that equivalent to? What is this area? This is what they want to find. Okay. What is the probability here? Find P. Okay. So we're going to use Z is equal to X minus mu over sigma, right? So Z is equal to X in the given example is 91. This is our X value here. Let's change the color of that. This is the X, right? Here's the mu and here's the sigma. So we have everything. So 91 now, 91 minus 100 divided by 15, okay? So Z is equal to 91 minus 100. That will be -9, and be very careful with the negative, divided by 15. And if I divide that by 15, now I have Z is equal to -0.6. Since I'm looking up 2 digits, so Z is equal to -0.60, right? So this is what I have to go and look up. So what have we learned here? This means, right? Let me do it in the bottom. That the probability for X, now be very careful, look at this picture. Which side is shaded, to the left or to the right? On this picture here, right? Which side of the graph is shaded, left or right?
The right side.
The right side. So when you go here, the probability of X greater than, right, 91 now. And that is the same as if I say this is non-standard. Here is the non-standard. If I go to the standard, that's the same if X is greater than -0.60. This is the standard. Okay. Now we're gonna have some work, because when you look up negative now, let's see if I insert my photo. What's this one here? Okay. If I look at this for -0.60, right? -0.60. So we want to look at this column. Oops. This column here, come on. This column here, and 0.6 would be negative, would be here. So where the two of them intersect will be this value here. And that value is 0.2743. Okay? 0.2743. So, but keep in mind, it means that this is 0.2743. Here we said that Z is equal to -0.60. But that's not what you want to find. Remember, when you look up values on this table, right? The value on these tables show you, if you look at how this picture, it's always from the left side, okay? Always. So how do we find this area here? Okay, to find it, the shaded, right? To find the shaded, what we're gonna do is this has to be 1 minus 0.2743. 0.2743. So 1 minus 0.2743 that is equal to 0.7257. And this is a probability, right? Probability is always written in 4 decimal places, okay? Now, does that make sense, right? If you look at this, more than half of the graph is shaded, right? Halfway of this will be somewhere in the middle here, okay? Close to. So the answer has to be bigger than 0.5. The answer should be bigger than 0.5. So we draw our normal graph, and then we convert these two values is what we want to know. What are the z representation of this? So we use the formula now. Z is equal to x minus mu divided by sigma. So z is equal to x in this scenario is 112 minus mu was given to you, right? Mu is 100 and sigma is equal to 15. So minus 100 over 15. So z is equal to, if you take your calculators, okay, 112 minus 100, that will give you 12, okay? And 12 divided by 15, so z here is equal to, if I divide 12 by 15, z is equal to 0.80. I always write 2 decimal. In the next case now, I want to know what is the z value when x is 124. So same formula, okay? So z is equal to 124 minus 100 over 15. So z is equal to now 124.
Mister.
Yes?
You put that, that's what I say, you put 112.
Yeah, 124. So this becomes 24 over 15. And 24 divided by 15, z is now equal to 1.60. So the values we've obtained now, okay, this value here, z is equal to 1.60. This value here, z is equal to 0.80. And don't forget, we want, let's change color, this area here. So you guys should be now experts at finding that area, because last class we showed how to find area of a portion, right? So what do we have? Right now we know that you were given probability of x, right, was between 2 numbers. It was less than 124 but greater than 112. So the probability of x less than 124 but greater than 112. And that has converted to the probability of z less than 1.60 but greater than 0.80. You guys should be aware of how to write this. Okay, so this is from non-standard to standard. Okay, from non-standard to standard. Any questions so far?
So we don't have to look it up in the table.
You have to. We didn't find the probability.
Oh.
Now is to find the probability. All you've done so far was to convert from non-standard to standard. Okay, so let's look up. Okay, what is when z is equal to 0.80? Okay, so 0.80, let's say, is here, 0.80, and then 1.60. When you look up 0.80, you're getting this area here, right? This is the area you're getting when you shade. Okay, so when you look up when you look up 0.80, what is your probability? Check your sheets and look up this value for me now, because you guys have to learn how to read your value. 0.80. So it's positive. It's positive. 0.80 will be
0.7881.
very good. Therefore, the area P here is 0.7881. Is that what I heard, right?
Yes.
Yes, good. That is correct. Okay. Now, when you look up Z equals 1.60, what you're really looking up is Z is equal to 1.60. You're looking up all of this, right? You're looking up the yellow and you're looking up the green that you want to find. So when you look up 1.60 now, when you look up 1.60 on your table, what value do you have?
0.9452.
0.9452. So how do we get the shaded? So the question is, what is the probability of the green part, which is less than 1.60, but greater than 0.80? Okay. So if you notice, you count that yellow piece twice, don't you?
Yeah.
The yellow piece was 0.7881, and when you got 0.9452, you're counting the green and the yellow. So how do you just find the green shaded region?
Subtract
Very
1.
good. Subtract.
Subtract, what's it called?
0.9452 minus 0.7881. You guys see what I'm doing?
Mm-hmm.
You guys see what I'm doing? Victoria, you good?
Yes.
Yeah.
Okay.
0.
Johanny, all right?
Yeah.
So what's the answer here now? What is 0.9452 minus 0.7881?
0.1571.
0.1571. So the probability here is that, or you can say, equal to 15.71%, right? So you could either write it as decimal or percent.
So it's negative 0.59.
So if we try this now, right? 62 minus 63.7, that will give me negative 1.7 over 2.9. Divide that by 2.9. So now, right, now you get a long decimal number, right? So now this is equal to Z is equal to negative 0.586206.8, right? But your table, you can only look up two values. So negative 0.59. You can only have up to 2 decimal places. You follow? So this value here that you're going to draw, this value that you're looking up is Z equals negative 0.59. Now we want to know what this value is. Okay, because this is the area that you want to find. Right? This is what the Navy accept. They accept anyone between, I think it was Navy, right? Yeah. The Navy accept, okay, the requirements of height is between 62 and 78 inches. Find the percent of women meeting the required height. Okay, good. So now we want to know, what is Z equal to when X is equal to 78? So Z is equal to X minus mu over sigma. Z is equal to now 78 minus 63.7 over 2.9. Okay, so Z is equal to, if we try that, 78 minus 63.7, that is 14.3 positive. Divide that by 2.9. So Z is equal to, if I divide that by 2.9, I have a long decimal again, 0.931. It's not 0.93.
4.931.
14.3. It's 14.3 divided by 2.9, right?
Yeah, the answer is 4.93.
4.9310 on and on. So we have to round it to 2 decimal places. So that's become 4.93. Okay. So this value here is 4.93. That's Z equals. And we want to find this area here. So how do you write that as an inequality? Well, first you were given the probability of X is, right? X was less than 78, but greater than 62. And we converted that now to Z, and that is less than 4.93, but greater than negative 0.59. So keep in mind, when you look up 0.59 negative, when Z is equal to negative 0.59, right? What you guys are really getting is a value from here, negative 0.59, going this way. So negative 0.59 value would be 0.2776. 0.2776, please confirm.
Yeah.
And when Z is less than 4.93, this is a value you don't even have to look up, because anything on your table bigger than 3.4, okay? When you look up 4.93, if you look up on your table, anything bigger than 3.49 is 0.9998. So when you look up this value, you get 0.9998. So anytime, guys, this value here is bigger than 3.49 or 3.5, the answer will always be 0.9998. So what's our probability now? The
I have a
probability,
question.
yes.
Is it 0.9998 or 9999 when it's
It's 3 9s and an 8.
My paper says 4 nines.
mine has 4 nines as well for 3.5 and up.
Okay, it doesn't matter.
No? Okay.
9999. So you're saying you have an additional 9 here?
Yes. Because in my
There's no 8.
yeah, there's no 8.
The
But I don't know
value
if
you
that
wrote is the
affects
value for
it or not. That's why I asked.
3.49.
Okay, 3.0 is the next row of, okay. I mean, that's one, it's 1 over, you guys are correct based on the table you're looking up, yes. Okay. It's almost 1. So you guys are correct. So now the probability of Z less than 4.93, but greater than negative 0.59 would be 0.9999 minus 0.2776. Okay, so 0.9999 minus 0.2776 is 0.7223, or you can write 72.23%. Okay, so if we go back and we look at our question now, okay, so find the percentage of, and they asked for percentage, right? So you have to write it. Are many women not qualified because they're too short? So look at the percentage here. Would you say that many women are qualified or not qualified?
They're mostly qualified.
Mostly,
Yeah, they're mostly qualified, right? Because almost 75%, let's say 72.23 is almost 75. Almost 75% of women height, okay, are between 62 and 78. This was inches, right? Yes, inches. Any questions?
No.
Now, if you look at part B, so part B is a little bit different, right? So if the Navy changes the height requirements so that all women are eligible, except for the shortest 3% and the tallest 3%, okay? Be very careful now. Shortest 3% and tallest 3%. Now, is that 3%, guys? 3% represents what value? Well, first of all, if we draw a picture of it, maybe that will help. So for part B, okay, they're saying that now we have a graph, okay, and the Navy will now change it so that all women except, okay, except the shortest 3%. So the shortest 3% will be somewhere over here, right? This is the shortest. And the tallest 3% will be somewhere over here. Do you agree?
Yeah.
So this is 3%, this is 3%. Now notice where I write that 3%, right? Percent is a probability, isn't it? Pay attention, guys, because this one is a little bit different. Percent is a probability, isn't it?
Yes.
So what you have to do now, okay? So keep in mind, these are probability. This is a probability. 3% is the same as 0.03. Okay? How do you get that? 3% is 3 over 100. Okay? Which is 0.03. Now, so this here is also a probability. Okay? So I want to show you something now. Before, okay, before you were looking at a z value, okay? You were looking up some z value and you were finding the probability, right? That's what you were looking up before. Now it's different. Now they're giving you the probability. These values in here, all of these values all about here, these 4-digit values represent probability, okay? All of these red values are probability values. Do you follow? These values out here are Z values. Okay? These are Z values. So where do you have to look for this value 0.03? In the blue circle or the shaded red?
The red.
The red. So we have to look carefully, and sometimes you don't find the exact value. You have to find the closest one. Now notice that these values here, right? These are 4-digit decimal values, right? 4 digits. So usually what I recommend is write this as 4 digits, 0.0300. 1, 2, 3, 1, 2, 3, 4, yes. So we're gonna look up in here now for 0.0300. 0.0300. So let me change color. 0.030300.
The closest thing I found is 0.0301. Is that the same thing?
I know, I'm looking. That's where that dot is,
Yeah,
right? Blocked out there.
yeah.
This is, oops. Somewhere here is closest, right? 0.0301, isn't it?
Yeah.
Maybe I should circle it with that value. So what is the Z value that matches that value now? What is the Z value that matches that value? Negative 1.88. Class?
Yeah.
The Z value that gives you 0.301 is negative 1.88. Do you agree?
Yes.
Yes, good. So it means, okay, we have made big progress now. It means that for 3%, this value here has to be Z equal negative 1.88. Well, these graphs are symmetric. So if this is also 3%, what do you think this value here will be?
The same.
No, a little
A positive 1.8.
positive. Positive. Very good. Positive. Okay. So go back to the question. I don't know. I don't think we answered the question yet. The question is asking you if the NAGI changes the height requirement, what are the new height requirements? So they want you to find the X value now. So what X will give you this value? So remember, we know that Z is equal to X minus mu over sigma, right? Now we have Z, we want to find X. So negative 1.88 is equal to X minus, what was mu in this example? We have to look and see if they're talking about women or men.
7.
Women, right?
Yes.
We're talking about women. So the women mu is 63.7. So this becomes 63.7, and the standard deviation is 2.9, I think. Anyone copy it?
2.9, yes.
2.9, yes. So if we cross multiply, this is like over 1. If we cross multiply, okay, we have negative 1.88 times 2.9. This becomes negative 5.452 is equal to x minus 63.9. And then if we add 63.9 to both sides,
Isn't it 63.7?
was it?
Yes, it's 60.
That was our mu, right?
Yeah.
63.7, yeah, 63.7, thank you. $63.7. So we have to add 63.7 to both sides, right? So minus 5.452 plus 63.7, that becomes 58.248 is equal to x. Now x represents the height, so you could round this to 2 decimal places. They didn't specify. So this is approximately 58.2 if you want 1 decimal place, or you can say 58.25 if you want. Inches, right? Remember, it's inches is equal to x. So the shortest you can possibly be, if they said the bottom is 58.2 of an inches short. Now, what's the tallest you can be? Okay, what's the tallest you can be? So the same thing we have to do for this side now. We have a positive 1.88. Same formula, right? Z is equal to x minus mu over sigma. So x minus 63.7 divided by 2.9. And if you multiply that now, you'll get a positive 5.452 is equal to x minus 63.7. And then if you add 63.7 to both sides, okay? So what is 5.452 plus 63.7? This becomes 69.152 is equal to x. So here we can say that x is equal to 69.2 inches or 69.15 inches. So anybody height, right? So your height range now is from 58.2 to 69.2 or 58.25, and don't forget these are inches, right? To 69.15 of an inch. If they decide to change their range, this is the new height requirement. So where do you stand a better chance? Do you stand a better chance with the bottom 3% exempt and the top 3, or anyone who is between 62 to 78 inches? Okay. So you should be able to answer that question. These are all questions that can be asked. Question, guys?